Hey, my name's Brian, and today I'm excited to introduce you to our web app, Cheap Chess Tutor. Along with our team, we have 6 people, myself, James, Eric, Chris, Will, and Drew, and we're all excited to show you the different parts that we worked on. Together, we each worked on different features of the app, as well as the basic app management processes, such as managing GitHub and testing and things like that. Overall, our app is a simple chess game, but it leverages artificial intelligence to help a new chess user learn the game by providing the chess user with possible moves or suggested moves. Now, that's the surface, but beneath that, our main goal was to test the limits of text-based artificial intelligence, such as ChatGPT 3.5 Turbo, and see how far intelligence can go to teach new students things that are complex or difficult, human students, such as chess. We were inspired by a fellow student of ours who showed us how to use it, and we decided to apply it to the chess problem set by translating a chessboard into text, having ChatGPT analyze that text and give us responses in terms of possible chess moves or suggested chess moves, which we then translate back into visual effects that the user can interact with on a chessboard in real time. And we got it to work. I'm happy to report that we got all 7 major required features for minimum viable product completed for our app, including about 50 test cases and 60 issues that we worked together as a team before deploying it to Amazon Web Services. And if you want, you can actually try it for yourself. We'll provide the link in the chat and have fun. So moving on, our overall design is backed by 6 core technologies: React, PostgreSQL, Django, and 11 enabling technologies to make it all come together. But overall, we strove for simplicity, a bare minimum of requirements for a minimum viable product, and then a very simple database design and schema. So with that said, I'll turn it over to Eric, who will demonstrate the basic game menu functionality and game controls.
Hey everyone, this is Eric, and I implemented some visual content within the project, and I am here to demonstrate some menu and controls functionality within it. Once we first load the page, over to the right we have a game board that renders, and over to the left we have our menu. Below we have 2 input boxes where we can put in our email and password, as well as a sign up button where we can sign up and create an account. For time's sake, we're just going to go ahead and sign in. Once we sign in, it takes us to a page where it greets the user. Over here, we can also choose where we want to play as light or dark, and we can create a new game. We can also join an existing game by pressing this button. And over to the right, we still have our empty game board. We're going to go ahead and choose light, press a new game, and it takes us to the actual game page. Over to the right, as you can see, our game pieces have loaded into the game board, and over to the left, we have our game controls. Underneath the game controls, it shows which players have joined. If you click on a piece and you press that suggest move button, it can suggest a move that you can make with one of the pieces. We also have a show file / rank labels where it shows the position of each square. If you also click on a piece and you try to move to an invalid square where it cannot go, there's a little shake area for continuous gameplay. James and Chris can demonstrate the game further.
Thank you, Eric, for going over the game menu functionalities. My name's Chris, and I'm here with my partner James to show a demo of the gameplay flow. So to talk about the game state real quick before we begin, our game isn't solely saved on the front end. Everything is saved in the back end in our database, allowing users to play multiple games at once or rejoin a game that they're currently in if they accidentally close a tab. But for time's sake, let's just go to the gameplay, and I'll turn on the rank labels and make my first move.
So Chris went ahead and made his first move, e2 to e4, and now that it's my turn, as a new chess player, I'd like to check out some of the functionality of the different options that might be provided for possible moves and maybe some recommendations too. So using OpenAI ChatGPT, I'm going to go ahead and suggest a move and see what it recommends. And right off the bat, we can see that we're running into some of the issues that we've found with ChatGPT, some of the limitations, because it's recommending that I move my pawn from d7 and capture his pawn at d2. And for several reasons, that's just not possible in a game of chess. So if I select this piece, we can see that the possible moves are actually moving it up to d6 or d5. So if I try that again with Stockfish and ask for a suggested move, it's going to recommend moving my pawn from e7 to e5, which is actually a pretty decent move. But as a new chess player, I'm feeling pretty confident, and I want to move my pawn from f7 to f5 and challenge his pawn at e4.
All right, thanks, James. So here I can showcase our capturing of pieces, making sure that, we follow chess rules as the state of our game updates to reflect that behavior. So as you can see here, I'll move my e4 to attack his pawn at f5, which pretty much shows that a piece has an onboard function of true or false. Right now it is true. If I capture that, it sets it to false and removes that piece from the board. So now it's James' turn to make his move.
Awesome. Thanks, Chris. So I'm sure you guys were able to see that my screen is just a couple seconds behind his, but we're able to keep up. And I'm going to go ahead and turn on the Python chess for possible moves, because I know that Python chess is a little bit more consistent than ChatGPT. And I see Chris is moving his pawn up the board pretty far, and I want to do the same. So I'm going to move from g7 up to g5.
All right, thanks, James. As we can see here, I look like I'm in a good spot, but I want to be sure, so I want to ask Stockfish for a move suggestion. But I also want to show ChatGPT first, because let's see what ChatGPT says about a move suggestion. So right here, it tells me to move b2 to b3, but I don't really need to move there. I want to attack towards the right side of the board, so let's go ask Stockfish for a move suggestion. As you can see, it's suggesting my queen from d1 to h5 to try to threaten the king. So let's go ahead and do that. Oops, sorry about that. I forgot to hit this checkbox. So moving my queen from d1 to h5.
Right, here comes the pop-up. Congrats, Chris. You won the game. And we know that Chris won because he was able to put my king in checkmate, which ends the game of chess. And we know that because we're able to check against the Python chess library, which provides a comprehensive list of legal moves in the game of chess. Up next, we have Will, who's going to go ahead and demonstrate his implementation of a player versus computer game.
I'm Will. I will be demonstrating the functionality for playing a chess game against the computer. So here I'm logged in as user. All I have to do is click on this checkbox, play against computer, and then click on new game. Then here my game renders. I am player 1, player 2 is computer, and saying it's your turn. So I will just move a random square. So here, and then the computer moves, and usually the computer is very quick to move. It usually does not take more than a second for them to think of a move. Their move is generated from ChatGPT, and that move gets validated against the Python chess library to see if it's a valid move. And so here I am just going to take his pawn. That's a free pawn right there. Now it's computer's turn. Computer moves there. And now I am actually going to ask Stockfish for a suggestion. Stockfish is a really good API for chess. Its ELO rank is like 3,600, which is crazy. It's like an all-time high. So it's a really good assistant for getting help for chess moves. So here I'm going to click suggest move. And it suggests that my knight moves up. So I will do that. Then computer's turn. Computer moves that pawn up. I will actually suggest another move from Stockfish. And then the other knight comes up. And so the computer moves that knight. So the computer sometimes, because it's querying ChatGPT for suggested moves, it can be hit or miss in like their move selection. And so sometimes it's not the best. So I will take that knight with my bishop. And so you see here how ChatGPT, yeah, how the computer just ignores that that obvious move right here, and it just moved this bishop somewhere else. So here I am going to move this here, and then it also ignored that move too. So sometimes it's hit or miss. Sometimes the computer is very good in its suggested moves, and in this case, not so much. So here I am going to take that. Okay. I will get actually a suggested move here from Stockfish. So it's saying knight to e5. And so computer moved its queen out. So I will actually get another suggested move here. It's saying my queen out. Okay, I see what's trying to go here. And then, so yeah, it moves its bishop. It doesn't see the threat. I suggest another move, which is me checking its king. And then it has to move its king that way. And so I will suggest move here. I will take its bishop. Then move its king back. I will actually take this rook here. So in this case, the computer is very bad today. So it's it does not recognize like what I'm doing, or like it's not countering any of the stuff that I'm doing. So that's why I look like such a great chess player, even though I'm all right. So here it's check. It's actually checkmate. Never mind. So here I won. It was pretty easy. And so, as you can see, I use AI to play against a computer that was assisted by AI. And so it definitely helped me in that Stockfish is actually a better chess player than ChatGPT. And so I use assistance of Stockfish to defeat a ChatGPT assisted computer player. And so I feel like that might be the future of chess. Who knows? But as for our platform, which is a chess educational platform for beginners who are learning how to play chess, it definitely does help to have a really good computer assistant helping you make moves so that you learn stuff and you have fun in the process. And so definitely it makes chess a lot better to play with. And with that, I will kick it off to Drew.
Hi, my name is Drew, and to wrap up this presentation, I'm going to be talking about some of the challenges we faced and our future plans for the project. The first challenge we faced was learning how to work with the GitHub flow so that every member on the team could simultaneously work on the code and push updates as they were completed. As you can see on the screen, we overcame this challenge with a strong planning phase of our project, in which we set up GitHub issues on our project to handle features, of which we were able to complete around 60. You can see each one of them listed here along with their priority and description tag. We each volunteered for features we felt strongly about and then tackled them through an equal share of individual hard work and pair programming, and then pushed our features onto the main branch only after face-to-face demos and code review. Another challenge we faced right away was learning the code base, which is on the screen now. Specifically our AI prompts for our API requests to OpenAI, and on the other tab is our dependency injection, which we used to build out our project's functionality. Brian set our project up with a very strong foundation and offered many demos to get the rest of the team caught up to speed, but for many of us, this is the first time we had taken somebody else's project and really understood it and contributed to it enough to call it our own. To accomplish this, it required a strong understanding of the code, which we gained through said demos, reviews, and most of all, not being afraid to ask questions. This taught us all the versatility required to jump onto any project and thrive. While we are all impressed with how far this project has come from the beginning, we still have ambitious plans for it beyond Platoon graduation. Some of the things on our roadmap that we hope to implement in the near future are additional gameplay features, such as the ability to reverse a move, adjust the computer difficulty, and a chat feature so the players can enjoy live communication during the match. I think I speak for everyone on the project when I say thanks for viewing our presentation. We are so grateful for each other's hard work, and we can't wait to show everyone the potential of cheap chess.
All right. Thank you so much, Chess Tutor. Again, Chess Tutor was built by Brian, Drew, Chris, Will, James, and Eric. At this point, we would like to open up the floor for some questions.
One question I had was there an unexpected challenge or like an unexpected thing that you learned along the way from doing this group project that you wouldn't have, thought would have happened going into it?
That's a great question, Adam. Yeah, I mean, there's more than I can count. One of the big ones was we used this library on the front end called Axios that allows us to make data request calls over the internet to other websites. And man, that thing, it works great in a development environment on my local computer. But once I maybe move that into like a deployed environment, or even set it up on someone else's computer, it behaves kind of unpredictably. And the workaround that we identified for that is just being very explicit in all of our calls with that tool to always provide it everything it could possibly need, such as credentials or keys or whatever. And after we started doing that and got to that habit, some of those glitches started to go away.
Thank you.
Yeah, I guess I have one question real quick too. I think it was with Will, but anyone feel free to share. Could you kind of share some more insights on the challenges you faced whenever you were integrating that Stockfish API you were using to analyze the potential moves?
Yeah, there were challenges in terms of like the API that we were querying. We first went with Rapid API, but since there were different, it wasn't as reliable as the actual Stockfish engine, which we eventually went with. And plus, like in terms of the data that we had to send over to the API, we had to put it in a special way. It's called Fen notation, which is like a special chess notation that's like, it's like R1, like rook 1, and like it has like all the piece positions and stuff. And so we had to pass it correctly or it wouldn't read it the right way. And then it was sent back gibberish if it didn't read it correctly. Yeah, I hope that answered your question.
Absolutely. Thank you. That's cool, man. Really cool.
So this is Cassandra, and I do have a question for you as well. I noticed that ChatGPT periodically does go down. Do you have anything in your application to notify the user if that is a problem, or what steps did you take to remediate any potential outages, or how to deal with outages?
Hey, that's a great question, Cass. So for ChatGPT in particular, which is one of 3 tools that our backend server can reach out to for data, when ChatGPT in particular fails, and we did see this a lot, we can default to a different library on the front end and just say randomly select one of the many possible moves that the backend provided, as opposed to maybe a suggested move that ChatGPT suggested. We have talked about wrapping the the server side calls in more error functionality, and same with the front end, but we didn't get as far as we'd like to with that. In fact, sometimes we'd almost gone too far in providing the error messages because, after a game was over and someone got congratulated, we were getting an error message because the computer still wanted to play or something. And so we kind of we knocked that off for the time being and saved that one for a future iteration. I hope that answers your question.
I have one more question, if you don't mind.
Absolutely, Yams. You were the inspiration for this effort here.
Oh, yeah, I appreciate that. Well, my question is with the two-player interactivity, how are you dealing with real time? If one player makes a move, how does the other player then know that the move was done?
Yeah, that's a great question, and I'm sure there's a very standard and professional way to handle this. Because we were in kind of an agile sprint 2 weeks setup, we just did the bare basic implementation for this type of two-way responsiveness over the internet, with the the backend server acting as the persistence and the intermediary between the players. And so what we did was we just basically set a timeout function call on each person's browser that would wait 5 seconds and then pull the server for any updates with the game state, which would provide all kinds of data. And we would conditionally set this timeout function to only ask for fresh data if it's not your turn, or if the game hasn't started yet. If it is your turn, and say you're kind of deciding on where you want to move, and maybe you've got some squares highlighted on the board, we don't want to interrupt that interaction, so we halted the request for game updates during that time while the user is interacting with their own board on their turn. Does that make sense?
Yeah, absolutely. It was always a question on my mind, and I thought that was a smart way to deal with it.
All right, awesome. We seem to have one last question from our YouTube channel. Are there any other APIs you may have implemented to make features such as playing against the AI more difficult for more experienced chess players?
I think it'd be really interesting to explore, the ecosystem of chess AIs. There are probably many more than we even were exposed to during this short exercise. But in the near term, one of the easiest things we could do is allow the user to select a difficulty level. And if they wanted like an easy difficulty, well, then that would vector them to ChatGPT as their opponent. Because ChatGPT sometimes, as Will was saying, sometimes can be good, but more times than not, it's either unreliable or just not doesn't show high expertise. If the user instead selected a more advanced opponent, that would vector the computer to use Stockfish, which is much more established. And in the greater scheme of things, it shows the versatility of OpenAI and ChatGPT is its strength. It can be used to cover so many topics. But once you get very precise with a certain topic, its ability to deliver consistent, reliable, testable inputs kind of goes down, and that's where you'd really want to use a more targeted AI engine that's designed for a certain complex use case. And currently the more precise AI seems to outperform the more general one. But that's why we did this experiment, to see, okay, how far can we go, and how long will it be until the generalized AI surpasses the targeted design one? I hope that answers the question.
And yeah, to add to what Brian said, it's not necessarily an API that we could have implemented. Also, we could have put like a feature that was like beginner, medium, or hard level for that for Stockfish, and could have just changed the difficulty that way.
All right. Thank you so much. Again, that was Chess Tutor by Brian, Drew, Chris, Will, James, and Eric.